This is Activity 3, Space Rocks and the Price of Rope, from Lesson 12, Using Graphs to Compare Relationships. And the first part of this activity is looking at space rocks, a meteoroid, Perseid 245 or 245, and asteroid X, and how fast they are traveling through the solar system. So the graph shows the distance each traveled after a given point in time. And notice that their speed is a proportional speed. It's not speeding up or slowing down. They're moving at a steady speed or a steady rate. Is asteroid X traveling faster or slower than Perseid 245? Explain how you know. Well, you can solve this problem in a couple different ways. One way is, first of all, for both objects, distance traveled is on the y-axis. So this is how far the space rock has traveled over time. So this is distance, and that distance is proportional to the time. So this is time down here. So how far has it traveled, that distance, in how much time? How far has Perseid traveled, that distance, in how much time? All right, so one way to look at this is to look at the same distance for each space rock. Let's just say it's a mile. Now that's not very far as space objects travel. They travel very, very fast. But let's just say, for example, call this a mile. So asteroid X in 1 mile will have taken this amount of time. Let's say 1 minute. And Perseid 245 in that same 1 mile will have taken 2 minutes. Taken more time to travel the same distance. So who's traveling faster? Asteroid X is traveling faster because given an equal distance, it takes less time. So now let's say that you and a friend of yours is running from your classroom to the library. So that's the same distance for both of you. And who's running faster? Well, it's the person that gets there first. Let's say it takes you 1 minute to get to the library, and it takes your friend 2 minutes to get to the library. You have run faster. You have gotten there first, so you have covered that same distance in less time. That is a faster speed. You're traveling faster. Now, another way to look at the same problem is to look at the same time. Look at 2 minutes rather than same distance. Look at how far each travels in 2 minutes. So in this case, for 2 minutes, go up to the graph for Perseid 245, and this is going to give you the distance over here. And you go up to asteroid X, and this is going to give you the distance over here. So in 2 minutes, which is the same time for each, Perseid 245 travels 1 unit, let's say 1 mile, and asteroid X in 2 minutes travels 2 miles. So asteroid X in that same amount of time, 2 minutes, travels twice as far. Perseid 245 travels half the distance. Okay, so now let's say you and your friend are running from your classroom to the lunch tables, and you measure how far you've run in 2 minutes. Well, your friend makes it all the way to the lunch tables in that 2 minutes. You've only made it halfway. So your friend in this case is running faster. So who goes farther in the same amount of time is moving faster. So again, asteroid X is the faster space rock. So it travels farther in the same time, moving faster. So the best way to study these is to draw these graphs, draw the arrows, and talk through with a friend or write about which is faster, which is slower, based on their position compared to equal time or equal distance. All right, so let's look at another example of pricing of rope. So you have cotton rope. This is the price on the y-axis. So how many dollars? How much does it cost? And this is the length on the x-axis. And it says if you buy $1 of each kind of rope, so that's going to be the same price. So $1 of each kind of rope, which one will be longer? Explain how you know. So let's look at $1. And so for the cotton rope, $1, you get this length of rope. And we'll put a number on that in just a second. And for the nylon rope, you pay your $1 and you get this length of rope right here. So for $1, which one gives you the longer rope? It's the nylon rope. So that $1, let's say it gives you 2 feet of rope for cotton, and you get twice as much rope. 2 times 2 is 4 feet for nylon. So that same $1, you walk in the store, you give the cashier $1, give me all the rope I can get of cotton, they give you 2 feet. Give me all the rope I can get for nylon, they give you 4 feet. So nylon is less expensive. You get more feet of rope for that $1. So less expensive, more length for an equal amount of money. And another way to look at this is rather than look at $1, look at 1 foot. How much does 1 foot of each rope cost? Now this is not what the problem asks you. The problem says look at $1. But if it said which rope is less expensive, another way to look at it would be how much money does it cost me to buy an equal amount? So in this case, 1 foot. Different store, the pricing is a little bit different. Let's say that for nylon rope, for your for 1 foot, it costs you $1. For cotton rope, for that same 1 foot, it costs you $2. So the cotton rope is more expensive. So you have to pay twice as much money to get the same length. So cotton is more expensive than nylon. So nylon's less expensive, less money for equal length. So let's put these both into a table. Let's go back to the tables that we've used in the past. Nylon rope, cotton rope. X is going to be the length. It's down here. The length is on the x-axis. Y is going to be the price on the y-axis. In the case of the nylon rope, the constant of proportionality is going to be $1 per 1 foot. 1 divided by 1 is 1. So the constant of proportionality for nylon rope is 1, but the constant of proportionality for cotton rope is $2 per that same 1 foot. So the constant of proportionality for cotton rope is 2. So it has a higher constant of proportionality, so cotton rope is this steeper slant right here. Costs more. So this is the constant of proportionality for nylon and the constant of proportionality for cotton. But let's say that let's go to the second, actually it's the first example. Let's say that we go back to the first example and you're given $1 in each case. So $1 of nylon rope is going to give you 1 foot. It's the same. So now we're going the other way, but it's $1 per 1 foot. So it's the reciprocal of 1 is 1. So you multiply it back the other way. It's still 1 foot of rope for nylon. But what about cotton? Now the reciprocal of 2 is 1/2. So now we're going to multiply the other way. So $1 times the reciprocal this is $2 per foot. So that's 1/2 foot per dollar. So that's the price for $1 is one. The price for 1/2 of a foot is $1. So $1 times 1/2 gets you just 1/2 a foot of cotton. So this cotton is more expensive. You get less amount for the same amount of money. So more dollars for an equal length. So it costs you more money. So right here for an equal length, 1 foot, cotton costs you more money. So more dollars for an equal length, but it's less length. So 1/2 of a foot and 1 foot for an equal number of dollars. So more dollars for an equal length, less length for an equal number of dollars. So more dollars for an equal length, but less length, 1 foot and 1/2 foot for an equal number of dollars. When you compare prices at a store, you want to make sure that you think about the information that's provided in this first row. That is called the unit price. So for example, nylon costs $1 per 1 foot or 1 unit of rope. So the unit price is $1 per foot. Cotton rope costs $2 per 1 foot or $2 per unit, which in this case the unit is 1 foot. So cotton is $2 per foot, nylon is $1 per foot. So that tells you that's the constant of proportionality. So if the y-axis is the price, $1 and $2, then the constant of proportionality will tell you the unit price. So $1 per unit or $2 per unit. So make sure that you focus on that unit price when you are shopping at a store.